Hi, so this session is on quadratic functions and revision on all of this. So looking at quadratic equations as well as drawing parabolas and analysing parabolas. So we have a practice test that we'll be going through. And our first question on the practice test is this one here. And it asks us the equation of the graph below could be, so we've got a graph over here and we have to figure out what the equation is for this graph. So this is the graph that's given to us, and based on this information, we have to come up with an equation. So let's see what is actually given to us. We can see that the turning point is over here, where y is -5. And what's the x value of the turning point? Well, the x value of the turning point is 0. So this turning point, its coordinates are when x is 0 and y is -5. And we can get this just by looking at this graph over here. And based on this information, we can actually come up with a quadratic equation in turning point form. You notice that nothing else is given to us. We aren't given any x-intercepts, so we can only put this in turning point form. Now we assume that, so turning point form is here, y equals a bracket x plus h or minus h squared plus or minus k. So if you remember that turning point form, h is the x value of our turning point, but the opposite. K is the y value of the turning point, and that stays the same. Now, a is a factor, and if there's a number out here other than 1, for example, if I had just say y equals 2 out there, just say, that's telling us because it's greater than 1, our parabola will become more narrow. Okay, but when we come up with an equation now, we assume that a is equal to 1. So we assume that our parabola has the same width or the same dilation as our basic parabola. Okay, so now all we're going to do now is put in our x value and our y value into this equation. So y equals, so a is 1, bracket, well, the x value is just going to be 0, and the y value is -5. And there's the equation for this parabola. Now you notice that we have a 0 here, so we actually can write this now like this, y equals x squared minus 5. We don't have to write this plus 0 because 0 means nothing, nothing there, so we just have x squared minus 5. And that is the equation for this parabola here. Okay, so if we have a look at our options for the multiple choice, where are we? You notice that it is B. So x squared minus 5. And you notice that over here they've got a -5 in the brackets, but be careful, that -5 in the brackets refers to the x value of the turning point. And we can see the x value of this turning point is 0. The next question asks us, which of the graphs below could represent the following equation? Okay, now, before we pick a graph, let's look at this equation here. Now, if you have a look at this equation, you notice that there is no y value for our turning point. This is in turning point form, and we can see that. And the y value for the turning point is really 0. If I put a plus 0 there, you can see that. And the x value of our turning point, x is equal to, it'll be -2. So if we were to draw this, it is saying our parabola hasn't translated up or down. It's simply translated, in this case, -2 is over here. Just say, we'll put it there. So it's translated 2 units to the left. Now, to draw this, if y is 0, the parabola will just come down, touch the x-axis, where x is -2, there's a turning point, and keep going. Remember, this here is the x value of our turning point, and our turning point is when x is -2 and y is 0. So at that point there, where the parabola just hits the graph, that is where y is 0, but x is -2. So remember, whenever you see a quadratic equation that's a perfect square, just say we had this, we call these perfect squares. This is where, if I was to show this in 2 brackets, I would have this, y equals x minus 1 and x minus 1. We know that that's what it's saying. And if I had to solve this to find the x-intercepts, I would end up with this, x equals a +1 and x equals a +1. You notice how we end up with the same solutions? because you can see we have the same number in both brackets. And so with this example, it's telling you we have actually one solution or one x-intercept. And we know parabolas can have two x-intercepts. They can have no x-intercepts, or they can have one. And these are the examples where the parabola has one x-intercept. It's where you see something like this, a perfect square, no other values, no y values, just the x value, so a bracket and a square. And because it's squared, it's a perfect square, saying the two brackets are the same, so the x-intercepts are the same. So we say there is one solution, because we actually don't have two different solutions. We have two that are the same, so we just end up with one. So out of these graphs, which one looks like that? And you can see it's this one here. C or D, I guess, because D's dropped off, so it's actually C. You can see how the parabola just hits at -2 and keeps going. This one here, at B, unfortunately, you can see with B, it's actually being translated 2 units down. So we would have ended up with a -2, but not in brackets. Okay, and that one's been translated 2 units up. So we would have had a +2, but not in brackets. The y value has changed. Our next question, which of the parabolas below will be the widest? So we know for a parabola to become more, its dilation to change and for it to become wider, we know the number in front of the x squared, or the factor outside the bracket, has to be less than 1. This is because if it's less than 1, the values will be increasing at a slower rate. So, for example, if I have, for example, y equals 2x squared, and we can see 2 is greater than 1, that means if I use a table of values, I'll end up with larger values because we're multiplying everything by 2. And so they're getting larger, the y values are getting larger, especially, much quicker. If I, for example, have y equals 0.5x squared, I'm multiplying everything by a half. And when we multiply something by a half, we are actually dividing it in half. Multiplying by a half and dividing by 2 are the same thing. So if we're dividing everything by 2 and halving it, that means our parabola will become much more wider because the y values are increasing at a slower rate. So if we have a look at the equations here, which out of these numbers is the smallest? 0.1, a half, a 1's there that's invisible, or a 2? Well, clearly 0.1 is the smallest, so this parabola will be the widest one. The next question asks us the translation to turn the basic parabola, y equals x squared, into the following parabola. What changes have to be made? So we know this is in turning point form, so we can actually see the turning point, but it's not asking us that. All we got to do is, remember, we started off with y equals x squared. There is our basic parabola. And what changes do you see? Well, I can see there's a +1 here, but really, x will equal -1. So just remember that. So that's one change. And also there's a -3 here, which is another change that has been added. So there are two changes happening. This +1 here, when we know it's really x is equal to -1, we can say, so on our graph, there's left and there's right, and -1 is just here. So our parabola is moving to the left, or translated to the left 1 unit. And -3 moves, it's translated down, sorry, that changed colour, down 3 units. So let's have a look and see which option that is. Left 1 unit and down 3 units. Left 1 unit, down 3 units. You can see it is C. Oh, sorry, it is D. So 5 asks us to state the equation of the axis of symmetry. We know the axis of symmetry is a vertical line, and it has its own equation when x equals something, and cuts a parabola in half. So we can see here that the turning point is when x is 2 and y is -1. So when x is equal to 2, that is the axis of symmetry. So to write the equation of this, all we have to do is say x equals 2. And that is an equation for a straight line. If you were to draw this straight line on a graph, when x is 2, it's telling us x can only be 2. So our straight line will come down. Whoop, that failed. Try again. It will come down and pass through 2. So x can only be a positive 2. So our parabola on that graph, what happens is the turning point is when x is 2. So the parabola is cut in half when x is equal to 2. This line actually cuts the parabola exactly in half. So the axis of symmetry is actually the x value of the turning point. So question 6 asks us to write an equation for a graph where the x-intercepts are 3 and 4. Okay, so I've just drawn a quick sketch of what the parabola may look like. We're not given any information if it has a maximum or minimum turning point. We're just asked to write an equation based on this information only. So remember, to put this back in factor form, we would have this. The x-intercepts can be put into brackets, okay? And we have x and x. And what goes here is the opposite of what we see. Because we've got a positive 3, we now put a minus 3 in the bracket. And because we've got a positive 4, we put a minus 4 in the bracket. Because we know when we solve this using the null factor law, x will equal positive 3, x will equal positive 4. They are our x-intercepts. And now, to put them back in brackets, we just do the opposite. The opposite of what we see is negative 3 here, and the opposite here is negative 4. And now all we have to do to write the equation, yes, this is actually an equation, but it's in factorized form. So all we're going to do now is expand this and simplify and write our final equation. So we end up with, y equals, well, x times x is x squared, minus 3 times x is minus 3x, and then minus 3, but we'll do it again. X times x is x squared, minus 3, and then x times minus 4 is minus 4x, and minus 3 times x is minus 3x, and minus 3 times minus 4 is positive 12. Sorry about that. And we have y equals x squared minus 4 minus 3, that's minus 7x plus 12. And there is our equation based on the information given to us for our parabola. Okay, and let's see if that's an option. So we've got x squared minus 7x plus 12. Where is it? X squared minus 7x plus 12. We can see that the answer is D. With question 7, it asks us the turning point and y-intercept for the following graph is what? So first of all, is this in turning point form? Yes, it is. So here's our equation here. So yes, this is in turning point form, and we know this here, the opposite of what we see is the x value of our turning point, and that's the y value. So straight away, our turning point is simply when x is positive 4 and y is negative 2. Okay, so we know it's the opposite of what we see in the brackets. Turning point, done. But now we also have to find the y-intercept. And to find the y-intercept, it's when x equals 0. So be very careful. Don't just think the y-intercept is negative 2. This is not in a trinomial form. So we have to make x equals 0 and work it out. So y equals, when x is 0, we have 0 minus 4 squared minus 2. 0 minus 4 is just minus 4. And minus 2. And minus 4 times minus 4. Remember, it's in brackets. So minus 4 times minus 4 is a positive. 16. And we've got the minus 2 there. And finally, 16 minus 2 is 14. And there is our y-intercept. So the turning point is when x is 4, y is negative 2. The y-intercept is when y is equal to 14. So our answer is D. There it is. Okay, so that was the first section of our practice test. And we'll do the next section in another session. Thank you.